Good evening. Good evening, everyone. You're welcome to today's edition of the tutorial. Today I'll be taking you on what we call Contactor. As you can see, Contactor is a component, is an electrical component or device that can operate in on higher load. What I mean it can operate on higher load is Contactor is different from relay. Relay can operate on lower load. Understand? But Contactor has the capacity to operate on higher load. Is a component that that can open and close circuits. And it's an open and closed circuit. And let me show you how the Contactor works and how it looks like. For example, this is our Contactor. Let's assume this is our Contactor. This is our Contactor, and it has let's assume this is our Contactor. Our Contactor has features inside the company. It has many features, and I will explain each and every features. The work is each and every feature is doing. Now, for example, you can see now it has NO contact and NC contact. What do we mean by NO contact? Keep on watching. I will explain that further. It also has the coil. This is the coil section side, which is the A1 and A2. This is the coil side, and this is the contact side, and this side is the power side. The L1, the L2, the L3. Here our T1, T2. Now, this is our Contactor. As you can see, this side, L1, L2, L3 is the source, is the incoming power side, while the T1, T2, and T3 is the outgoing power side, which is going to the load or to the electric induction motor pump. So this side is going to the majorly to the load. So now, if our Contactor is energized, this A1 and A2, this is the energizing part. This is the call side, because if the Contactor is energized, it's going to give power to flow from L1 to T1, power to flow from L2 to T2, as well L3 to T3. Now, how does this circuit, this component works? Look at it. This is the NC side, and normally we do say our NC is normally closed, while our NO represents normally open. As it is now, there's a point here. This NC point at this side, automatically, normally, if we should check our continuity from this side to this side, is going to what? There's a continuous continuity that flows from here, from this side to this side, and this is the sign. This is the sign you're going to see. This is the sign NC. If you should take your multimeter and read from here to here, you can see it's closed. While here, this is the symbol. You're going to see this is open. That means normally open. Now NO is normally open. Now the circuit here is open. That means if you should use your meter to check the continuity from here to here, it will not read, it will not sound, there will not be continuity except this is being energized. That is where you're going to see the continuity will flow from here, from this side to this side. So normally NO normally open is the continuity flow, and when the continuity flow, it will energize the coil of the contactor, and this coil of the contactor we call it A1, and here we call it A2. This side you can as well connect your live wire here, and this side you can as well connect your neutral wire. So if you should connect your live wire here and neutral wire, then automatically the contactor will be what? Energized. And once it is energized, it will give passage for power to flow from the L1, L2, L3 down to the what? To the load side. This is the load. It's going to the what? This is the load side. It's going to our 3-phase motor. 3-phase motor. So it's going to, this is the source and this is the load. So this is how the contactor works. Let me repeat myself. There is the power side. The power side represents L1, L2, L3, T1, T2, and T3. While the coil side in the contactor represents the A1 and the A2. In every contactor component, you must surely you will see your A1 and A2. It doesn't have polarity. It's either you put your live wire on A1, you connect it on A1, while you connect your neutral wire on A2. So it does, the coil doesn't have polarity. And why this is the contact side? We have the contact side, we have the coil side, and we have the what? Power circuit side. This is the contact side. And this side is called auxiliary contact. We call it auxiliary contact. We call it auxiliary contact because it's from when the power is sent to NO. So NO will automatically hold the coil. So when it holds the coil, there's a flow from, there's a power from here. Power has come to this, reach this side, and come to this side, and then hold the what? The coil. So when it holds the coil, the contactor will what? Energize. So when the contactor is energized, this one NC what? There will not be flow of current from this side to this side. This one will dis-energize, and why this one will energize? So if this contactor is not energized, if it's not energized, there will not be flow. There will not be flow of power from here, this NO to this side. So and then automatically there will be flow of power from NC automatically. So this is how contactor works. As you can see, this is how the contactor works. Then after this side, I'm going to illustrate how we can do the control wiring of the contactor. I hope you understand and you enjoy the video. Thank you very much. I remain my humble self, Engineer John. See you in the next video.